Welcome to this brief lesson on z-scores. Z-scores, what are they good for? Well, let's say, for example, Matt is a senior in high school and he's applying for college. And in his application, it asks for him to record or report his best standardized test score. I have two scores here. Let's say, for example, Matt scored an SAT of 1720 and an ACT score of 24.5. Which one of those should he report? Well, there are two different types of data from two different types of tests, so on the surface, it's kind of impossible to figure out which one is best. The 1720 is obviously better than the 24.5 as far as raw scores are concerned. But if you have any knowledge of the two different tests, scores are not comparable. So what we need to do is normalize them. We need to compare these scores to their relative populations. So in order to do that, we need more information. First, as far as the SAT, we need the mean and standard deviation, or the center and the spread of the data. Let's say, for example, the mean SAT score is 1550, and the standard deviation of the SAT is 200. In the ACT, we have a mean 21.0 and a standard deviation of 3.0. So now I have a better sense of which one did Matt perform better in. He performed better than the mean for both the SAT and the ACT. I'm still not 100% sure. Now that I have this information, I want to normalize the information, or normalize the data. So the first step in doing so is to sketch a normal curve. Even though it's a freehand sketch, it's going to give you a good sense of where the data is relative to each other. If you recall, a normal curve is symmetrical with the mean at the middle. I'm going to put 3 tick marks going above the mean and 3 tick marks going below the mean to represent, each one of those tick marks represents a standard deviation. I'm going to copy this. I'm going to paste the copy of it over here so that I can compare the two of them. So let's plot the SAT score. The SAT had a mean score of 1550. If each one of these tick marks represents 200 points for the standard deviation, this next one should be 1750. Next one, 1950, and so on. Since 1720 is my score, I can see that 1720 lies right around here, just below that one standard deviation. All right. Now let's plot the ACT score. ACT had a mean of 21.0, with each one of these tick marks representing the standard deviation of 3. So this one is 24. This one is 27. This last one is 30. So a score of 24.5, I have a value just above one standard deviation from the mean. By comparing those two graphs, you can see that on the surface, the ACT score was higher. Now let's take a look at the formula for the z-score and find the actual data points. If you recall, the formula for the z-score is the value of the point minus the mean, with that difference divided by the standard deviation. And that takes place for each one of these. So the z-score for the SAT, I'm going to put a little subscript of S there to indicate for the SAT, I have 1720 minus 1550, all of that divided by 200. That yields the z-score positive 0.85. That is the z-score for the SAT. The ACT, again, follow the same steps. I'm going to use the subscript of an A now. I have the value of 24.5, which was his test score. Subtract from it 21.0. And from that answer, I divide by 3. And that yields a positive z-score of approximately 1.17. So I'm comparing those two values, positive 1.17 to positive 0.85. I have the data now, or the z-score, to tell me that the ACT is the test in which he performed best. The ACT is the test he should report his greatest score. I hope that helps. Have a good day.